Okay, so what we're going to do is, all right, we're going to talk about the 6 trigonometric functions. We're going to evaluate trig functions. We're going to evaluate trig functions both by hand and using the calculator. So you will need your calculator. And we're also going to take a look at reference angles. First, we're going to start out with the 6 trig functions. And as far as the 6 trig functions are concerned, if you take a look at the all exam formula sheet, you'll notice that the 6 trig functions aren't actually on this formula sheet. Now, I don't require you to memorize the formulas or anything to that effect, but these 6 trig functions that we're going through now, they're like the crux of the course, and some memorization of these is required. All right, so on this 8.2 set of notes, all right, we're going to talk about the 6 trig functions. All right, so here are the 6 trig functions. We have sine, cosine, tangent, cotangent, secant, and cosecant. We're going to let x and y, we're going to let x and y be a point other than the origin on the terminal side of our angle theta. So we talked about all of our angles are in standard position. The distance from the point to the origin, which is nothing more than a radius. R, which is equal to the square root of x squared plus y squared, and thus we have the 6 trig functions. So notice we have that the sine of some angle is y divided by r. The cosine of some angle is x divided by r. The tangent is y divided by x, and then we have our reciprocals. The reciprocal for sine is cosecant. The reciprocal for cosine is secant. And the reciprocal for tangent is cotangent. All right, so notice that the sine is y over r, and its reciprocal, the cosecant, is r over y. When we talk about the unit circle, and I'm going to bring that document up. In the unit circle, r is equal to 1. So if we were to go back momentarily to our formula sheet, well, not to our formula sheet, but our actual formulas. Okay, which are here. Notice that r would be 1. So the sine of any angle in the unit circle would simply be the y value. Okay. So if r is 1 and we're actually finding the cosine would simply be the x coordinate or the x value for your angle. Notice that the tangent is y over x, and its reciprocal to cotangent is x over y. There is no r in either the tangent or the cotangent. Notice that for the cosecant, we have r, which in the unit circle is 1, so we have 1 divided by the y coordinate. And the secant, here again, r is 1, so we have 1 divided by x. So notice when you're using the unit circle, right, the sine is simply the y coordinate alone because the radius is 1, and the cosine is the x value. So for example, if we wanted to find the cosine of 30 degrees, right? If we wanted to find that using a unit circle, how will we find the cosine of 30 degrees? Well, keep in mind that in any ordered pair, we have x and a y coordinate. In the unit circle, the x coordinate is the cosine of some angle. The y coordinate is the sine of some angle. So if we wanted to find the cosine of 30 degrees, we would simply locate 30 degrees. We would look at our x and y coordinates, and since we're finding the cosine, we would use the x coordinate. Right? So I'm going to go back to the unit circle. So if I were asked to find the cosine of 30 degrees, I would simply find 30 degrees, which is pi over 6. I would locate the x coordinate, which is the cosine, and I would have that value as the square root of 3 divided by 2. Right? So that is the cosine for 30 degrees. Let's say we wanted to find the sine of 2 pi over 3. Well, in order to find the sine of 2 pi over 3, I would find 2 pi over 3 in my unit circle. And then since I'm finding the sine, I would look at the y coordinate. So I want to find 2 pi over 3, which is 120 degrees. I want to find the sine, which would be the y coordinate. So the sine of 2 pi over 3, again, is square root of 3 over 2. And we'll find one more. So let's find the tangent of 45 degrees. Okay, now one thing about the tangent, if we go back to our set of notes, the tangent would be the y coordinate divided by the x coordinate. Now, as far as the unit circle is concerned, we don't actually have the tangent or cotangent values. We simply have the sine and the cosine, or the x and the y value. So I could, in order to find the tangent of 45 degrees, I can take the y value for 45 degrees, which is square root of 2 over 2. I can divide that by the x coordinate of 45 degrees, which again is square root of 2 over 2. I can simplify and find the tangent value. So for the tangent of 45 degrees, I can write that out as the sine of 45 degrees over the cosine of 45 degrees. So keep in mind that the sine value is y and the cosine value is x. The sine of 45 degrees is square root of 2 over 2. The cosine of 45 degrees is also square root of 2 over 2. And we simplify to give us a tangent value of 1. And then we'll also do one more. We would find, let's say, the sine of 30 degrees. Right, so in order to find the sine of 30 degrees, again, we would locate 30 degrees. We would find the sine, which is the y coordinate, and we would have a value of 1/2. All right, so that's how you would use the unit circle to find the table of values. Excuse me, that's how you would use the unit circle to evaluate a trig function. Now, there's some angles in which we're going to be asked to find the trig values for that are not in the unit circle. For example, here we're asked to find the sine of 126 degrees. Now, normally in the directions, if you're asked to use your calculator, it'll tell you in the directions to use your calculator. But here we can clearly see, if we look in the unit circle, right? There is no 126-degree measure, right? It simply goes from 90 to 120 to 135. So how can we calculate the sine of 136 degrees? Excuse me, the sine of 126 degrees. Well, in order to calculate, we're going to use the calculator. All right, we're going to use a calculator. Now, there's just a couple things I want to explain about the calculator, and they haven't played a factor in anything that you've probably done up to this point with the calculator if you haven't been using your trig functions, the sine, cosine, and tangent. Okay, so I'm going to turn on my calculator. Now, whenever we use our trig functions, the mode of our calculator is very, very, very important. So what do I mean when I say the mode of our calculator? So I'm going to put in, well, first of all, so I'm going to hit mode just to see what mode my calculator is in. So once I hit mode, I want to pay attention to the third line, which is the radian and the degree measure. Right? So I'm just going to do a couple things. So notice that I'm in degree measure. So if I'm in degree measure, right, 2 plus 2, that equals to 4. And let's say I go into my calculator and I change my mode to radians, right? So I have radian highlighted and I'm going to hit enter to actually select radian mode. And I'm going to go back to my home screen. So I'm going to hit clear and, second and quit. And in this mode, 2 plus 2 is also equal to 4, right? So if you've been doing basic arithmetic, the degree radian mode doesn't matter. However, if you're using a trig function, the mode you're in matters. And here's what I mean when I say that it matters. So I'm going to go back into mode and keep in mind that we're in radian mode. So let's say I wanted to find the sine of 30 degrees. Notice that it gives me negative 0.988. Now I'm going to go back into mode and I'm going to change my calculator to degree mode. Now notice when I enter the sine of 30 degrees, I get a total different value. Okay, so here's the difference between the two. You want to make sure that the mode of your calculator matches what you're actually putting into the calculator. For example, notice we used the sine of 30 degrees. When we were in radian mode, we got a negative 0.9. But when we change our calculator to degree mode, so keep in mind we are inputting in a degree measure, notice we get the correct value of 1/2, which is 0.5. Which brings the point that you want to make sure that your calculator is in the correct mode. If you're dealing with radian mode, you want to make sure your calculator's in radian. If you're dealing with a degree measure, we want to make sure our calculator is in degree. So notice that we're in degree mode and we're asked to find the sine of 30 degrees, right? Notice we get 1/2. I can also find the tangent of 45 degrees, right? Since I'm in degree mode, I'm putting in a degree measure, okay? And notice it gives me the correct value of 1. So let's just say we wanted to, and my screen is not moving down. Okay, let's say we wanted to find the sine of 2 pi over 3, right, using the calculator. The first thing I would have to do is make sure, since I'm putting in a radian measure, I have to make sure that my calculator is in radian mode. I'm going to put in the sine of 2 pi divided by 3. Right, and notice I get 8.866. Okay, now the calculator won't give me any radicals, but if I sort of cross-check this, I can put this in as the square root of 3 divided by 2, and notice you should get that same exact value. All right, so just a hint, when you're using a calculator, you want to make sure that you are in the correct mode. All right, so to find the sine of 126, we want to make sure that we are in degree mode, right? Because we're putting in a degree measure. I'm going to put in the sine of 126, and we get 0.809. 0.809. All right, so this is how we would evaluate trig functions by using the unit circle as well as the calculator. Now, there's one other place where you can find or you can evaluate trig functions, and I'll just kind of reference that to you at this time. I'm going to go back into the Blackboard shell, and in this formula section, I'm going to click on unit circle function values chart. Right, so if I click on this chart, it gives me the 6 trig functions. Right, it gives the sine, cosine, tangent, and the reciprocal formulas for every angle in the unit circle. Right, so let's say if we were to take a look at our problem earlier where we were asked to find the tangent of 45 degrees. And I can actually use the chart, okay, this particular chart to find that value. I can locate 45 degrees. I can locate tangent, and I see that the tangent of 45 degrees is 1. Right? If we wanted to find, let's say, the sine of 2 pi over 3, right, we can find 2 pi over 3, which is 120 degrees. We can find the sine, and we can pull out that sine value. Right, so you can evaluate trig functions by using the unit circle, by using this table of values, and or by using the calculator. All right, now I want to bring up, okay, one last thing as far as the trigonometric functions are concerned. Now, if we're dealing with an angle that's not in the unit circle, right, in order to calculate r, you would have to use the following formula. R is equal to the square root of x squared plus y squared. So with that in mind, I pose the following question. If the cosine of t is equal to 5 over 6, and is in quadrant 4, find the sine value. Right? So we're asked to find the sine of t. Right? So I'll give you a second to copy that down. It says if cosine t is equal to 5 over 6, right, and it's in the 4th quadrant, we're asked to find the sine value. All right. So before we actually begin this problem, one of the things we're going to do in a little bit later today, we're going to talk about what a reference angle is, and this sort of ties into this problem slightly. Okay. So before we answer this problem, we're going to talk about what a reference angle is. Right? So I'm going to just go over a little bit. So a reference angle in a nutshell, a reference angle is an acute angle. Right? So that's all a reference angle is. It's an acute angle. And based on our definition of an acute angle is just an angle that measures between 0 degrees and less than 90 degrees. Right? So whenever you're asked to find a reference angle, you're simply asked to find an acute angle. All right, so next I'm going to draw an X and a Y axes. And in this course, there are several what you call mnemonic devices. And a mnemonic device is mainly a saying that helps you to remember a formula or a pattern. So the mnemonic device that I'm going to use for our reference angle is this. All students take courses. All right, so what does this allude to? It alludes to the fact that the A, S, T, C, they mean something as far as this reference angle chart is concerned. It means that, okay, so I have 4 quadrants. Here I have quadrant 1, I have quadrant 2, this is quadrant 3, and this is quadrant 4. So the all student take courses, it means this. We have A, S, T, and C. Right? So notice my pattern. All students take courses, starting with quadrant 1 and ending with quadrant 4. All right, so what does this mean? Well, it means that A in the first quadrant means that all 6 trig functions are positive. Right? So the sine is positive. So whenever you see greater than 0, that simply means positive. The cosine is positive, the tangent is positive, and the reciprocals. The reciprocal of sine is cosecant, that's positive. The reciprocal of cosine is secant, that's positive. The reciprocal of tangent is cotangent, and that's positive. All right, so that's what the all means. The S part for students, it means that in the second quadrant, only the sine and its reciprocal are positive. Everything else is negative. Right, so in the second quadrant, the cosine is negative, the secant is negative, the tangent and the cotangent is negative. The only things that are positive are just the sine and its reciprocal, the cosine. In the third quadrant, T, which alludes to take, it states that the tangent and its reciprocal, the cotangent, are positive. Everything else is negative. And then in our last quadrant, the C for courses, it states that the cosine and its reciprocal, the secant, are positive. Everything else is negative. All right. So this is the start of our reference angle chart. It gives us the signs for each of our trig functions in the four quadrants. Well, so how does that help us with our problem? Well, the angle itself, which in this case the angle is t, it's in the fourth quadrant, right? So if I'm in the fourth quadrant, the only things that are positive are the cosine and the secant. Everything else should be negative, right? So if I look at my problem, notice that the cosine is positive 5/6. I'm asked to find the sine of t. So just by the fact of our reference angle chart, I know that the sine value should be negative. So the sine of t is equal to some negative value, right? Now, if I look back at the six trig functions, right, the sine is the y-coordinate divided by the radius, or r, right? The cosine is x divided by r. So if we're given x and y, we can find r, right? If you're given r and x, you can find y, or if you're given r and y, you can find x, right? So as long as you're given two parameters, you can use this Pythagorean theorem to find the third parameter. All right, so we're looking for the sine, so we need the y value and we also need r. Right, so how do I find the y value and how do I find r? And we'll notice in the cosine, we were given that the cosine of t is equal to 5/6, right? So from our six trig functions, the cosine is the x value divided by r, right? So x is going to equal to 5 and r is going to equal to 6. So I have to find y, right? So how do you find y? All right, so I'm going to add to the six trig function. So the sine of some angle is y over r. The cosine of some angle is x over r. The tangent is y over x. And then we have our reciprocals. The reciprocal of sine is cosecant. The reciprocal of cosine is secant. The reciprocal of tangent is cotangent. And then we have r is equal to the square root of x squared plus y squared, right? Which is what we have from our lectures, from the lecture notes. I'm going to add these two. X is equal to the square root of r squared minus y squared. Y is equal to the square root of r squared minus x squared. All right, so I'm actually going to add these latter two, right? Which just gives us some formulas if we need to find x or if we need to find y. Which in this case we do need to find y. All right, so I'm going to use a formula to find y. So y is equal to the square root of r squared minus x squared. I'm going to substitute r for 6 and x for 5. So y is equal to 6 squared minus 5 squared. So 6 squared is 36. 5 squared is 25. So y is equal to the square root of 11. All right. So now I have everything I need in order to find the sine, right? The sine value is r, which I just found is square root 11, over r, which is 6. Right, so we've answered the question. If the cosine of t is 5 over 6 and in the fourth quadrant, find the sine value. Well, the first thing we had to do was determine the sign of sine, right? So from our reference angle chart, we know that in the fourth quadrant, only the cosine and the secant are positive, right? All other values should be negative. So we determined that the sine was negative. Next, we proceeded to find y, right? Because in the sine, we need y over x. Excuse me, we need y over r, right? We had r and x. We didn't know y, so we found y. Right? And then we use the y value divided by the r value to find the sine. So at this time, I'm going to give you a problem. Okay, if I can find one. Okay, so here's a question. Use the given sine of the sine and cosine value to find the quadrant in which the terminal point determines or determined by t lies. Okay, so in other words, you want to tell which quadrant or quadrants that this angle lies in. So here's what we're given. The sine of t is less than 0 and the cosine of t is greater than 0. So for this particular problem, you want to find which quadrant or quadrant that t lies in. So at this time, I'm going to pause the recording. I'm going to give you 5 minutes or so to work the problem, and we will return with the solution. All right, now let's take a look at the solution. So we want to determine which quadrant our angle T lies in. Well, if we take a look back at the reference angle chart, the all students take courses, right? In the first quadrant, all six are positive. In the second, only the sine and its reciprocal. In the third quadrant, only the tangent and its reciprocal are positive. And in the fourth quadrant, only the sine, the cosine and its reciprocal are positive, right? So we're asked to determine this angle. The first thing I'm going to do is I'm going to start with the sign of t being negative. Okay, so if I go back to, well, I actually write it here. Okay, so we have all students take courses, right? So as far as the sign is concerned, the sign is positive in both quadrant 1 and quadrant 2, right? The sign is negative in quadrant 3 or in quadrant 4. Okay. So by the process of elimination, I'm going to cut out the first two quadrants, right? Because the sign can only be negative in the third or the fourth quadrants. Okay. So only the third and fourth quadrant can satisfy the first condition. The last condition says that the cosine has to be positive. So if I look at my last two quadrants, quadrants 3 and quadrants 4, the cosine is only positive in the fourth quadrant. Therefore, angle T lies in quadrant number 4. All right, so in order to determine which quadrant your angle lies in, you want to use the mnemonic all student take courses, right? And that alludes to the signs of the trig functions in each of the four quadrants. Right? So here we have that the angle T is in the fourth quadrant. All right, so lastly, we're going to finish up this reference angle chart. All right, so here we're asked this question, and we're going to finish up the reference angle chart. It says that a reference angle is an angle that's written as theta, okay, or theta prime, okay, and this theta prime notation is not a part of this textbook. And a reference angle is just a positive acute angle. We have to find a reference angle for each one of these angles, a 218-degree angle and a 5 pi over 6 angle. So in order to do these, we're going to finish our reference angle chart. Okay, so in this reference angle chart, we have all students take courses. All right, so we know what the all students take courses alludes to, and I'm going to just kind of erase that out. Now in the reference angle chart, since we are okay, give me 1 second. It appears to have crashed. Okay. Okay, so for the reference angles chart, right here we have 0 degrees. So keep in mind that a reference angle is a positive acute angle, so I'm only going to reference the positive angle. So we have 0 degrees, 90 degrees, and 90 degrees is pi over 2 radians. We have 180 degrees, which is pi radians. We have 270 degrees, which is 3 pi over 2 radians. And then we have 360 degrees, which is 2 pi radians. Now, if your angle is in the first quadrant, your reference angle would be your angle, right? Because if it's in the first quadrant, that angle is an acute, and the definition of a reference angle is an acute angle. If your angle is in the second quadrant, the formula for your reference angle would be 180 degrees minus the given angle. Or if you're dealing with radian measure, it's going to be pi minus the given angle measure. If your angle is in quadrant 3, the reference angle formula is the given angle minus 180 degrees. And if you're given an angle measure in radians, it's the given angle minus pi. And then lastly, in the fourth quadrant, the formula for the reference angle is 360 minus the given angle, or if you're dealing with radians, it's 2 pi minus the given angle measure. And this is the reference angle chart, okay, along with all students take courses. All right, so let's use this reference angle chart to find the following. Find each reference angle. Right, our first reference angle was, I go back for a second, 218 degrees and 5 pi over 6. All right, so we want to find a reference angle for 218 degrees. And then we'll take a look at one for 5 pi over 6. So the first thing to do in order to find a reference angle for 218 degrees, we first want to locate which quadrant that a 218 degree angle would lie in. So looking at our reference angle chart, a 218 degree angle would lie in the third quadrant, right? Because in the third quadrant we have degree measures from 180 to 270. So we would lie in the third quadrant. So I'm simply going to use a reference angle formula for the third quadrant. Right? So the reference angle would be the given angle measure, which is 218 minus 180. So once we subtract the 2, we get 30 degrees. Right? Therefore, 30 degrees is a reference angle for a 218-degree angle. All right, so let's find a reference angle for B, 5 pi over 6. And now here's the thing about degree and radians. If you're given the question in degrees or radians, you must answer in degrees or radians. So here, since I'm given a degree measure, I must answer with the degree measure. All right, so the first thing I'm going to do is just determine which quadrant a 5 pi over 6 angle lies in. And so in order to do that, I'm going to simply convert 5 pi over 6 to a degree measure. I'm going to find out where that lies, and then I'm going to just use the appropriate formula for it. So in converting 5 pi over 6 radians to degree measure, I'm going to simply multiply 5 times pi, but keep in mind that pi radians is 180 degrees, divided by 6, and we have a 150-degree angle. So if I look at my reference angle chart, a 150-degree angle is in the second quadrant. So in order to find the reference angle, I'm going to just use the formula for a reference angle in the second chart. In the second quadrant. So I'm given it's pi minus the given angle measure. So it's pi minus 5 pi over 6. So what I'm going to do is I'm going to just convert both the fractions. So I'm going to write pi as pi over 1, right? Now, whenever you subtract fractions, you must have a common denominator. So the common denominator between 1 and 6 is 6. Now I want to make equivalent fractions. So if I look at my first fraction, the denominator was multiplied by 6 to get the common denominator. So I must multiply the top by 6. Pi times 6 is 6 pi. That second fraction will remain the same. So now we want to subtract two fractions. So we keep the common denominator. We combine the numerators. And we have a reference angle of pi over 6. Right, so pi over 6 and 5 pi over 6 are reference angles. All right, so at this time, I'm going to give you a couple of problems to do. You want to find the reference angles for 140 degrees and negative 5 pi over 6. All right, I want you to find reference angles for both of these. I'm going to pause the video and we will return with the solution. All right, now we're going to take a look at the solution. First thing we'll do is we'll find a reference angle for the 140-degree angle. And if we go back to our reference angle chart, we'll see that a 140-degree angle, it lies in the second quadrant. And it appears to be hanging up on me again. Okay, it's not sticking. All right, so for the 140-degree angle, okay, apparently the OneNote is crashing. For the 140-degree angle, for our reference angle chart, it's in the second quadrant. So that reference angle formula is 180 minus the given angle, which is 140. So we would have a reference angle of 40 degrees. All right, next we're asked to find a reference angle for negative 5 pi over 6. Okay. Now here's the thing, since it's given to us in radian, we have to answer it in radian. But what I'm going to do is momentarily convert this to a degree measure, figure out the degree equivalent, and then convert that final answer to radian. All right, so here's what I mean. So we talked earlier that in order to quickly convert from radian to degree, we can treat pi as 180 degrees. So I'm just going to clear out things here. So on my calculator, I'm going to put this in as negative 5 times pi, which is 180 degrees, divided by 6, and we have negative 150 degrees. Right, so 5 pi over 6 radians is equal to negative 150 degrees. So keep in mind that on our reference angle chart, we're given all positive angles. So since I'm given a negative angle, I'm going to resituate our axes. So I have 0, and then we have negative 90 degrees, negative 180, negative 270, and negative 360. So that means that a negative 150-degree angle should lie in the third quadrant. Negative 150 degrees. Right, that angle is in the third quadrant. But if I go back to my reference angle, you notice that a reference angle is a positive acute angle. So the first thing I want to do here is I want to find the smallest positive coterminal angle for this negative 150-degree angle. And then once I find the smallest positive coterminal angle, I can then use the reference angle formula to find my reference angle. So the thing I'm going to do here is I'm going to take negative 150 and I'm going to add 360 degrees. Right? And we have 210 degrees. So remember, in order to find coterminal angles, it's simply a matter of adding or subtracting 360. Here we added 360. So now that I have my angle measure, which is 210 degrees, now I can find the reference angle. And if I use the reference angle formula for a angle that's in the 30 degrees, that reference angle formula says that it's the given angle measure minus 180. So 210 minus 180 is 30 degrees. Now notice that we were given the angle measure in radian, therefore we have to answer it in radian. So the last thing I'm going to do is convert 30 degrees to radians, and 30 degree as a radian is pi over 6. Right? So our solution to a negative 5 pi over 6, the reference angle to that angle is a pi over 6 angle. Right, so at this time, I'm going to go to the shared screen. I'm also going to stop the recording.